Okay, now let me go back and I will recreate all those three tables first. So let me copy. And I will go back here. I will create a customer and then vendor and then product tables. So let me create all three tables. Again, if you are running multiple SQL statements, don't forget each statements must be closed by this semicolon. So I can run all three all three. And sometimes if you cannot see tables, you can just refresh it. So click this up refresh button and then you will see all those three tables recreated. Okay, so I got all three tables and now I will add two more tables. So let's go back to editor and here I will create, since I have a customer, I can create invoice. However, I cannot create line first. So do you remember? Line is also linked with invoice. So without invoice, you cannot create line. So which one first? You must create invoice first. So invoice is also linked with customer, but we already have a customer, so there is no problem. So let's create table invoice. So to save some time, I will just copy and paste my code template, but you may want to write down from the scratch. So create table invoice, open parenthesis and close, and write down all the columns, data type, and also constraints, and I add primary key. I did not add one more constraint. What is the constraint? Invoice is child table of which table? Parent one is customer. So this is referencing the many-sided table. Foreign key is referencing. Key is referencing. So which foreign key? This table's which one? Customer code. So customer code column is referencing. So references which table? Customer table. So you can actually stop here because customer table is using same column customer code. But as I told you, it is good habit to explicitly specify which column it is referencing. So customer code. So customer code column. Good. So we have now invoice table statements. So let's run this table. So I will go back to Valhalla server, click SQL tab, and let's run create table invoice statements. Go. So actually now we have invoice table. We have 1, 2, 3, 4 tables. The last one is line table. So line table is a little bit more complex because it has a composite primary key and it has two foreign keys. So let me start with just all the columns and the data types. So let's start with this skeleton code and let me just close it here. And after you add all those column names, next one is primary key. For line, the primary key is composite of your invoice number plus line numbers. So these two numbers together will create the primary key. So in this case, same keyword, primary key, and parenthesis, and you cannot add another primary key constraint here. Instead, with this one primary key constraint, if you have multiple columns inside this parenthesis, you list up all the columns. So what is first column? Invoice number. So I will add invoice number and then separate this with comma, and the comma followed by, what's the next one? Line number. So I will add the line number. Again, I'm looking at the ER diagram and also the data dictionary together. So to figure out how did we design this table, the entity, in the conceptual design phase, we decided these two attribute as a composite identifier or primary key. Okay, now for the foreign key. For the foreign key in the ER diagram, if there are multiple relationships, we specify this as F1, foreign key 1, foreign key 2, like that. So we can have multiple foreign key constraints, although there is only one primary key constraint. So let's start with the foreign key, and then the first foreign key is referencing invoice. So let's start with invoice. Again, look at your ER diagram. This is associative entity. So this is connected with two entities, invoice and also product. So invoice number references and which table? Invoice table. And the invoice table has which column? Invoice tables invoice number. So invoice number. Let's specify this. And there is another foreign key. So we add one more foreign key constraint. So let me just copy from the top line. So foreign key, and it is referencing product. So product code. So this table's product code. So this line table's product code references product table's P code column. So P code column. Okay, so that's everything. So let's try to run this. So I will copy, go back here, SQL, and then double check whether there is any error. It's good. Click go. So now we have this line table. Okay, just as kind of last remark, let's look at line table and let's see the structure. And we have invoice number, line number as a composite primary key. So there is a PHP MyAdmin glitch. So when you have multiple foreign keys, it does not show the foreign key. In this case, for example, invoice number is referencing actually invoice table as well. So it is primary key, but at the same time, it must be foreign key. But it does not show silver key for invoice numbers. But if you look at relation view, you can see there are two constraints. Invoice number references invoice table. So there is foreign key exists in this invoice number as well. So don't worry about that. So again, in this case, invoice number is also silver key or foreign key. Good. So in this lecture, I demonstrated how to create those 5 tables. At the beginning, some of you guys might have some existing tables. In the same database, you cannot create 2 tables with the same name. So for example, if you have already customer table, there may be a chance you may need to delete that customer table before you create these new customer tables. So when you drop it, if you get any error with the foreign key constraints, I showed you how to resolve those issues. Okay, so before finishing this topic, as kind of last example, I want to demonstrate how to use alter table. Alter table means you want to alter the existing table structures. So alter table starts with alter. So let me write down here. Okay, so alter table. And suppose we want to add one more column to the product table. Then alter table, product table. And add, let's say I want to add one column. So for example, P sale code. And this is new column, so we may need to define data type. So character 1, for example. Just as an example, I just want to alter this table structure. So this can be executed here. So here, SQL, I want to add this. And then if I run it, it's successfully executed. So if you go back to product table and if you click structure, you can see this additional column has been added. So alter table is a part of data definition language DDL. And since we don't need actually this column, so let me just drop it. So you can see alter table product and drop this column. That's SQL syntax. So you can manually type it and you can run it, but I can just click this button. So I will click OK. So now I recover to original tables. So in this case, just for demonstration, I used it, but let me just delete it. So this is a kind of SQL statement you can run anytime when you screwed up with your tables, right? So let's keep this as a say copy, and I will save it in my local directory. That's everything about this topic, data definition and logical modeling topic. And I hope you can successfully create all those 5 tables